Welcome back everyone. This is just the continuation of the part 1 in which I have discussed the concept, very unique one through which you can solve this kind of problems, right, using a vertical circle and all those stuffs. So I have solved one Pathfinder problem in that video, and this one is also from Pathfinder MCQ section I have picked up, and I will discuss this one in this video. So let me read out the problem once. That in the setup shown, a thread is taut between a nail A on wall and a nail B on an inclined plane as shown in the figure. You can change the length of the thread by changing location of nail B. So basically B is a variable point where A is a fixed point. A bit that can slide on the thread without friction is released from the nail A. What should be the length of the thread B so that the thread reaches the nail B in shortest time? Again, I'm not going to discuss that conventional approach where you will take the components of acceleration along AB and using s equals to ut plus half at square, you can get the time as a function of B is a variable point, so you can take any parameter, right? So from the end point of the inclined plane, you can take the distance of B as x and write the time in terms of x, or maybe theta, where theta is the angle of between vertical and AB. You can write time as a parameter of one variable and then differentiate that to get the minimum time required, right? But I'm not going to solve in that manner. I'll solve using the concept I discussed in part 1. So let us draw this diagram here, only a rough diagram. So this one is the inclined surface. Here is the point A, and B is a variable point. This angle theta is fixed, and this height is also fixed as A is a fixed point. Now we'll assume some circles whose topmost point is A. Let's say we're assuming a circle like this. Or another circle whose radius is larger than the previous one, whose topmost point is also A. I'm drawing another circle. So like this you can take multiple circles, and the point is, when you talking about this smaller circle, so all these points on smaller circle can be point B. I'm taking the reference of part 1 where I have marked the topmost point as A and the other point of the path of this particle, as B, right? Let me write it more clearly. Yeah, so what I was telling, that if I drop the particle with initial velocity 0 along a chord like this or this or like this or this, all the paths will take same time, which is equals to root under 4r upon g, where r is the radius of the circle. And again, if you take the bigger circle, this one, then all this point, to reach all these points from A, the time elapsed will be same. And again on this circle, to reach all these marked points with green color, the particle will take same time to reach all the points from A. So that is the idea over here. But none of these circles are reaching to the inclined plane, so I have to take a circle of adequate radius which will reach the inclined plane surface. So let me draw that circle. In fact, in that case also we have infinite possibilities of circle. I will tell you that in what case it will be minimum. So I have to erase this one, I guess. Yeah. And this one was a vertical line. Sorry. Oh no. Take a line here. Yeah, this one is fine. So this point is A, the topmost point, and I'm drawing a circle like this, which is touching the inclined plane at one point. I mean, this inclined plane surface is tangent to this vertical circle, and so this will be AB. And as we have already seen that time is just dependent on the radius, and as the radius will increase, the time will also increase, and if radius decreases, time will also decrease. So we are supposed to find the minimum time, so we'll take the circle with minimum possible radius, and that will satisfy our condition. So why this circle will give minimum result? There, because if you take a circle of larger radius than this one, that will also pass through 2 points on the inclined plane, and but the radius will be larger. So root under 4r by g was our answer. We are just trying to find out for what r it is the minimum. If we get the r, we will just simply write time as root under 4r by g. Or wait, this is asking about the length, so we can relate anyway. We are just supposed to find that in what path it will have the minimum time. Then you can answer any of the questions, time or length of the thread, whatever. So I'm again repeating that minimum time will be elapsed in the case when inclined surface is tangent to this vertical circle. And somewhere here I am assuming the center, or let's make it as O only, because in part 1 I have taken the center of the circle as O. So I'm marking here also the center of the circle as O. Just relate from that part 1 that this AO was the vertical line here also. I mean, the diagram is not very much clear. I mean, absolutely not clear, because it is not seeming like the vertical line, or maybe O is the center, but please cope with this. So I'm joining OB, and as this one is theta and O is the center and inclined plane surface is tangent to the circle, so this angle must be 90 degree. So this angle will also be theta, because this one is 90 degree minus theta, and this angle is 90 degrees, so the marked angle is also theta. And using the concept that exterior angle equals to sum of opposite interior angles, you can write these two angles as theta by 2 and theta by 2. Okay, next, this one is also R, this one is also R, and from triangle AOB we can easily write that AB is nothing but 2R cos theta by 2. You just drop a perpendicular from here, from point O, and in this right angle triangle you can see that this length is R cos theta by 2, this is also R cos theta by 2, so AB is 2R cos theta by 2. Okay, now we have to find the value of R. So from this triangle we can write this length, I mean marking this with green color, that this length will be R sec theta, if I am not wrong, right? Yes, it is R sec theta, and OA is already R, so I can relate this with H, that H is R plus R sec theta. So R is H upon 1 plus sec theta, or I can write this as H cos theta upon 1 plus cos theta. Using trigonometry formulas, I am writing 1 plus cos theta as 2 cos square theta upon 2. So let's keep it like this. This one is my R, and I am supposed to find AB. So AB will be, here it's 2R cos theta by 2. So 2 into, I'm putting the value of R, because R was my matter of concern, that for what R it will be the minimum. Cos theta by 2 was also constant, and 2 is a constant. So we are just supposed to find the value of R in the minimum possible case, minimum possible time, right? So R is H cos theta upon 2 cos square theta by 2 into cos theta by 2. 1 cos theta by 2 gets cancelled in numerator and denominator. So AB, that is length of the thread, oh sorry, this 2 also gets cancelled, comes out as h cos theta sec theta by 2, and this is our answer for this question. I think option D was there. Yes, so this is the answer. Yeah, so it's very much helpful, I guess, in this kind of problems, this idea, because if you go when to solve this in conventional approach, I guess it will take 10 minutes almost, and still there are lots of calculations, so chances of calculation mistakes are there. So try to use this idea very frequently wherever it's possible, and if I also get in some other problems using this idea, I'll come up with other videos. But that's all for today, I think, and 2 problems have been already discussed on this idea. If you have not watched the part 1, I'm giving the link in the description. So thank you, that's all for today.